Hello, in this video, let's talk about the compounded interest. It's an example of exponential growth and it often happens in finance. So let's suppose that we have $10,000 and we can get 10% annual interest, which means at the end of 1 year, we're going to get all of our principal plus the 10% interest, which is $1,000. So at the end of 1 year, we're going to get 11,000. Now, if we leave that same money in that same account and get the same 10%, at the end of a second year, the interest, what we will get is we will get our original principal plus the interest, which now is $1,100. So the interest is going up because the amount is also going up. And now we have $12,100. And if we continue this way, we can find how much money we will have at the end of 3 years, 5 years, 10 years. What if we want to know at the end of 20 years? Well, we can continue to count like this all the way up to 20. We could also make Excel spreadsheet to do the same. But we can also come up with a formula that would allow us to do exactly the same with the press of a button. So let's make a formula. What are we doing here? How do these numbers come about? Well, we are taking our original amount. So the final answer, the final amount is equal to the principal, 1 plus the rate to the power of time. So what we are doing is we're taking our $10,000 plus the rate, and the rate has to be in decimals. So 10% is 0.1 to the power t, which is time in years. So this is our final amount for our particular numbers. Let's use a calculator to find what happens if time is 20 years. So here we can type in 10,000, 1 plus 0.1 to the power 20, and here's our answer. We would get $67,274.99. So basically we would round up to $67,275 because we round to cents, so that's 2 decimal places. So that's the answer for 20. We could also look at the table if we type in the same equation into y equals. So here's the same exact equation, but instead of the time, instead of the number fixed for the time, we have x. So this would find all the different x's, and if we look at the table, so here's after 5 years, here is the beginning. So in the beginning we have 10,000, 1 year later 11,000, 2 years later 12,100, and so on. So it's the same numbers we were just getting by hand, but with the aid of a calculator. And if we scroll down to the 20, we should see exactly the same number. Here is the same number, and it rounded for us, 67,275. So that's the answer for the compounded annual, because this interest was applied once a year. Now, if I wanted to have a general formula, I can make it even better by replacing rate with one letter, R. So this is our formula for the compounded interest if the interest is annual, just once a year. But many financial situations require the interest to be on different schedules. So it may be twice a year, semi-annually, or quarterly, 4 times a year, or monthly, 12 times a year, and so on. So we could get the compoundings could be once a year, twice a year, 4 times a year, quarterly, 12 times a year, monthly, could be weekly, that would be 52 compoundings, and daily, 365. So depending on what setup we have, we would need to use a different rate. We have to adjust the rate. Well, let's suppose we have the same question. We invested $10,000. We have 10% interest. We will use 20 years, but instead of once a year, we would use monthly, just like a car payment or a mortgage. So what happens is we take our rate, we have to take the 10% and divide it into 12 parts. But also that means there will be 12 times more compoundings than before. So to adjust this formula for any compoundings, we need to do the following. The final amount is going to be principal, 1 plus rate, divided by n. N is how many compoundings a year, to the power n times t. So this is the general formula that works for any compounding, no matter if it's once a year, twice a year, or any number a year. So this works for any number of compoundings. So to answer the question, how much money would we have if we put $10,000 and do monthly compounding, we would have 10,000, 1 plus rate, which is 10%, but now we divide it by 12 parts to the power 12 times t. Now these ends are the same, so if this is 12, so is this, and the time for us is not going to be, time is going to be 20 years. So we will put in 20, and now we type in all of it in our calculator and see what comes out. So here is redo 10,000, 1 plus 0.1 divided by 0.1 divided by 12 to the power 12 times 20. We have to make sure that both numbers are an exponent, otherwise it will not compute correctly. And the answer is 73,280 and 74 cents. So the answer is 73,280 and 74 cents. So we can see that there is 73,280, missed a 0, 80, and then 74 cents. So this is our final answer to how much money we would get if we use the same interest as before. But instead of compound it once, we compound it 12 times a month. And we can see with the calculator how much difference that made, because here are the two numbers, and we can see the difference between 67,000 and 73,000. In fact, we can subtract it to see how much difference that actually made to 7,475. So just by changing how frequently the compounding occurs, we gained extra $6,005.74. So the frequency of compounding is very important. And that's the formula for the compounded growth, no matter how many compoundings we have. And that's it for this video. If you have any questions on anything, please let me know in the comments, and I'll try to do something a little bit different. Thanks for your time. Take care.